Hi everyone, this is Ms. Deaver. Welcome to my online classroom, Algebra 1. This is Chapter 5, Lesson 1, Solving Inequalities by Addition and Subtraction. Okay, let's get started. In the past, you've solved equations by using addition and subtraction. In this chapter, in this lesson, you're going to solve linear inequalities by using addition and solve linear inequalities by using subtraction. Remember that the difference between an equation and an inequality is that in an equation you only get one value for the variable that you're solving for. In an inequality, you will get more than one solution that will satisfy the equation or make the statement true, or make the inequality a true statement. Okay, so as far as new vocabulary goes, in this lesson you will talk about set builder notation. This is read as the set of all numbers x such that x is greater than or equal to 20. And in this lesson and in this chapter, I do expect you to write your answers in what we call set builder notation. Alright, so here we have addition properties of inequalities. For all numbers a, b, and c, the following are true. If a is greater than b, then a plus c has to be greater than b plus c. And if a is less than b, then a plus c has to be less than b plus c. Now, if you're talking in terms of answers, I want you to consider adding some notes to your notes. And consider when you're talking about answers that there are two statements that are true. If A is greater than B, then it has to be true that B is less than A. And so when you're looking at solutions of inequalities, remember there are two statements that are equal and the same. Alright, let's start by solving by adding. And so here we have c minus 12 is greater than 65. And so we're going to solve it by adding, and then we're going to check our solution. So the first thing that we're going to do is we're going to write the original inequality. Then we're going to add 12 to both sides of the inequality, and we get c is greater than 77. Okay, so if you want to check this, now make sure that you write your answer in set notation. C is such that C is greater than 77. And then if you're putting that on a number line, you can check it to make sure you know which side of that to shade. Let's say that this is 77, and we'll put 78 here and 76 here, and we can check this. We want to shade the side that makes a true statement. We know that we want to graph 77 with an open circle because this is a greater than, not a greater than or equal to, and so we don't want a closed circle because we're not including the value of 77 in the solution. But we can check this by saying, okay, is 76 greater than 77? Well, no, it's not. So the side that's false, we don't want to shade. Let's check 78. Is 78 greater than 77? Yes, it is. And that means that we want to shade everything on this side of the equation. What we are graphing and shading is C. We're actually shading and graphing the variable. So to check, you need to substitute 77 and a number less than 77 and a number greater than 77. And so you would know that the solution is to set all numbers greater than 77. All right, let's look at k minus 4 is less than 10. Well, we know that if we add 4 to both sides of the equation, and then they're just showing you simple ones right now to get you started. We know that k is less than 14. Well, let's make sure that we're writing this in set notation. K is such that K is less than 14. So we know that B is our answer. All right, let's look at the next example. Here's a key concept on subtraction property of inequalities. We know that if A is greater than B, then A minus C has to be greater than B minus C. We know that if A is less than B, then A minus C has to be less than B minus C. All right, so let's solve the inequality. X plus 23 is less than 14. And simply going to subtract 23 from both sides of the equation. That cancels out. We're left with X is less than, let's see, -9. And if we're writing that in set notation, that is X is such that X is less than -9. And that should be C. Well, let's see, less than -9. Oh, I believe that's going to be A. Okay. So now let's run through that one more time. What do you do in order? The first thing you're going to do is read the test item. Second thing you're going to do is need to find the solution of the inequality. And you solve that just like you do a regular 1- or 2-step equation. You're going to subtract 23 from both sides of the equation, and you find out that X is less than -9. And then you want to make sure that your second step is to write that in set builder notation. And the answer is A. And if you're putting this on the graph, then you know that you're going to graph this. You can make a simple graph. It doesn't have to be very complicated. I usually just tell my students to make a mark, put your solution that you think is true. We want to put an open circle here because we know it's not going to include the -9. And then you need to make, I would probably add one number here and then one number here just to give it a reference. And then you need to shade either the left-hand side or the right-hand side to represent all the solutions for this particular inequality. And so we know that -10 is less than -9, so we would be shading everything to this side of the equation because it's true. Now I'm just going to check on the other side and put -8 in the place of X. Is -8 less than -9? Well, no, because the closer you are to 0, the higher the value. And so -8 is closer to 0, so that is actually more than -9. All right, let's solve this inequality. M minus 4 is greater than or equal to -8. All right, so let's add 4 to both sides. And we have M is greater than or equal to -4. So M is such that M is greater than or equal to -4. If we were putting this on the graph, we would have -4, and we would have a solid dot because it does include the -4. You have greater than or equal to. Now I'm going to put -3 here and -5 here, and I'm going to test my point -3 and -5 by putting it in the place of M. Is -3 greater than or equal to -4? Well, -3 is greater than -4, so I know that we're going to shade it to the right. But I am going to test -5. -5 is -5 greater than or equal to -4? No, it's less than. So I know I have the right side shaded, or the correct side shaded. Okay, variables on each side. So what you want to do is graph this solution. And so let's look at the original inequality, and we're going to start by probably subtracting 12n from both sides. You get negative 4 is less than or equal to n. Make sure that you're considering the equal true statement. If negative 4 is less than or equal to n, then n has to be greater than or equal to negative 4. And that might help you some with your graphing, because when you go to graph this, you know, you've got negative 4 on here, you need a solid dot. You've got negative 3, you've got negative 5, and you need to make sure that you're graphing this correctly. So you've got to consider that other equal statement that's also true. If negative 4 is less than or equal to n, then n is also greater than or equal to negative 4. And so when you test these points, is negative 4 less than or equal to negative 3? Well, yes, it is. That's true. Is negative 4 less than or equal to negative 5? No, that's not true. So you're going to shade this side. And this is where people get confused sometimes, because they try to shade in the direction of this inequality symbol without thinking about what makes the statement true. You're only going to shade the side where all the possible answers make a true statement. So be very careful with this. All right, let's have you graph this one. You have 3p minus 6 is greater than or equal to 4p. You might want to pause it, work your problem, and then I'll work it as well. I want to, let's see, I think I'm going to subtract 3p from both sides. So I know that that's a true statement, a true equal statement. So p is such that p is less than or equal to negative 6. So I know that that makes A my answer. All right, here you have some phrases for inequalities, and the common ones that most people know are less than or fewer than, greater than or more than, but you also need to remember that at most means less than or equal to. That's a maximum. And if you come across the wording at least, that's a minimum. And that means greater than or equal to. And so those are a couple of phrases for inequalities that you need to add to your vocabulary in mathematics. All right, here you have a word problem, and we want to use an inequality to solve this problem. Panya wants to buy season passes to 2 theme parks. If one season pass costs $54.99 and Panya has $100 to spend on both passes, the season passes must cost no more than what amount? So if it says no more than, then that has to be, you have a maximum. It cannot be any more than that amount. So we have $54.99 plus X has to be less than or equal to $100, because she can't spend more than $100. That's all she has. So it has to be less than or equal to that. So no more than is a maximum on that. She can't spend any more than that. All right, use the inequality to solve the problem. You want to subtract 54.99 from both sides of the equation, and you find out that x has to be less than or equal to $45 and a penny. So the second season pass must cost no more than $45 and a penny, or she will not have enough money to pay for it. All right, let's look at one more. Jeremiah is taking 2 of his friends out for pancakes. If he spends $17.55 on their meals, now remember he has to eat too, and he has $26 to spend in total, Jeremiah's pancakes must cost no more than what amount? If it's no more than, you need to know that that's a maximum. And so we have x plus $17.55 has to be less than or equal to $26 because that's all the money he has. So subtract $17.55 from both sides of the equation. And you're going to have x has to be less than or equal to $8.45. And if you're putting that in set builder notation, that'd be x is such that x is less than or equal to $8.45. Okay, that concludes Chapter 5, Lesson 1 on solving inequalities by addition and subtraction.